All right, we're gonna balance a reaction. All right, so we're going to balance an equation by the half reaction method. And to do that, so I have chosen number 12 from the extra practice that's posted online. The first thing we're going to do, so here we have this reaction, it's occurring in an acidic solution. And so we are going to break the reaction in half. We are going to look at the NO3- becoming nitrogen monoxide and the sulfite ion becoming a sulfate ion. So I will rewrite each of the half reactions. So we have NO3- becoming NO, and then over here we will have SO3- 2 becoming SO4- 2. Let's look at the nitrate first. So we have nitrate becoming NO. The nitrogens are balanced. There's one nitrogen on product and reactant. What's out of balance are the oxygens. And so in order to balance the oxygens, I'm going to add 2 water molecules here to the products. That fixes the oxygens but gives me 4 hydrogens there. So I'm going to come back over here and I'm going to add in 4 hydrogen ions. Those 4 hydrogen ions are going to give the reactant side a charge of +3, right? 4 positives and then a negative, so a total charge of +3, while the product side has a total charge of 0. So I've already balanced it in terms of atoms, but I need to balance it in terms of charge. In order to do that, I'm going to add 3 electrons over here to the reactant side, and now both sides have a charge of 0. Let's go look at the sulfite-sulfate reaction. So here, the sulfurs are already balanced. There's 1 there and 1 there. I will balance the oxygens by adding a water to this side. Now there are 4 oxygens on each side. That creates a deficit of hydrogen, so I'm going to come over here and add 2 hydrogen ions. Then let's look at the charge. Atoms are balanced, 2 hydrogens, 1 sulfur, 1 sulfur. This side currently has, so water is neutral, sulfite is -2, so this side has a charge of -2. Then when I look at the product side, we have the sulfate with -2 and the 2 hydrogen ions. So both of the hydrogen ions, so that's +1, +1, -2. This side is neutral. And so in order to balance that out, I'm going to add electrons to the more positive side, the neutral side. And I would need to add 2 electrons in order to give it a -2 charge to equal the reactant side. So now each half reaction is balanced. I need to recombine the half reactions into the overall equation. When I do that, the electrons need to cancel out. So the electrons are being transferred among the different species. We are not creating electrons. So if this reaction requires 3 electrons and this reaction produces 2 electrons, the least common multiple of 2 and 3 is 6. So I am going to take the entire nitrogen reaction and multiply it by 2. And I'm going to take this sulfur reaction and multiply the entire thing by 3. And so that will then give me 6 electrons plus 8 hydrogen ions plus 2 NO3- yields NO, 2 NOs plus 4 H2Os. Then I will rewrite the sulfur part of the reaction. So that's going to come down here. It's going to be 3 H2Os plus 3 SO3- 2s yields 3 SO4- 2s plus 6 hydrogen ions plus 6 electrons. And then, as I mentioned earlier, the whole goal of the multiplying was so that the electrons would cancel, and they do. Now I can combine the two reactions, two equations, into one equation. I'm going to combine all of the reactants and all of the products. And I'm just going to rewrite it as one long chain. So it's going to be 8 hydrogen ions plus 2 nitrates plus 3 waters plus 3 SO3 minus 2s yield 2 NOs plus 4 waters plus 3 SO4 minus 2s plus 6 hydrogen ions. Since there are some things that appear on both sides, there are hydrogen ions on both sides, there are waters on both sides, I can do a little bit of reducing. So since there are 3 waters on the reactant and 4 waters on the product, I can reduce that down. I can get rid of 3 waters on each side because 3 of them didn't really do any chemistry. 3 of them just jumped the arrow. So those 3, look how well that erases. 3 of those waters are gone, and then that would make this just a single water. And then the hydrogen ions, I have 6 on the products, I have 8 on the reactants, so I can get rid of 6 on each side, so I'm going to get rid of those 6, and then the 8, I get rid of 6, and that would leave behind 2 hydrogen ions. And that's going to be my overall equation. I don't think I'm going to rewrite it. So we have 2 hydrogen ions, 2 nitrates, 3 sulfites yield 2 nitrogen monoxides, a water, and 3 sulfates. Now I can check this and make sure that it is indeed balanced in terms of atoms and charge. So this whole side, this guy's got a charge of 0, that's charge of 0. There's 3 of those, and they're each minus 2, so that's minus 6. So this whole side has a charge of minus 6. We've got 2 hydrogen ions, 2, so that's positive 2. 2 nitrates, each with minus 1, so that's minus 2, so they cancel each other out. And then 3 minus 2, so this side is minus 6, and minus 6, that is very nice. And then we can just count up the atoms. We've got 3 sulfurs on each side, we've got 2 nitrogens on each side, looks like we have 2 hydrogens on each side. And then in terms of oxygen, we have 6 there, 9 there, so that's 15 oxygens. 12, 13, 14, 15 oxygens on both sides. So this guy is definitely the right answer. For an acidic solution, there's going to be a video that shows you then how to take this and turn it into a basic solution. So if you need to know how to just do the basic part, you can check it out there.